In this lesson, I'm reviewing algebraic properties with students to be able to apply their real number properties to literal equations. And so we'd start off with just a simple linear equation to talk about x plus 2 equals 4. Well, we use the inverse operation of addition, which just means that you're going to use the opposite number for the inverse of that number, subtract 2 in this case, to subtract from both sides. Whatever you do to one side, you do to the other, because that creates goes to 0 on the left, so we have x equals, and 4 minus 2 is 2. The same thing would be true if I had variables representing those real numbers. If I asked you to solve for a, in this case, you would subtract b, the inverse property of addition, and you would subtract b from the other side just to keep it balanced, and so a would be equal to c minus b. And I also emphasize the inverse property of multiplication, where if you had 2x equals 6, well, the inverse property of multiplication is I could multiply that times its inverse, which would be 1/2, or its reciprocal. And that's the same thing as dividing by 2 on both sides. I can multiply by 1/2 on this side. This goes to 1, and that's what I'm looking for, is 1 coefficient in front of x to show that I've solved for x, equals, and then 6 divided by 2 would be 3. Or you could have just shown dividing by 2 on both sides, same thing as multiplying by 1/2. And then if you had 1/4 x equals 6, then you can multiply by its reciprocal 4/1, or multiplying by 4 in the numerator goes to 1. Do the same thing the other side to keep it balanced, so x is equal to 24. Well, the same thing when working with literal equations. If you had area was equal to length times width for a rectangle, if I asked you to solve for the width of a rectangle, then you can manipulate the equation around by dividing by L. That goes to 1, L divided by L, and then area divided by length would be the width. So you could find the area of a rectangle, the width of a rectangle, taking its area and dividing by its length.